Hello, today we're going to be looking at part of section 10.3, which is about multiplying radical expressions. When we multiply radicals together, we can multiply any radicals. Unlike adding and subtracting, where the radicands must be the same, we can multiply anything together. When we multiply two radicals together, we always multiply the numbers that are outside of the radicand, and then we multiply the numbers that are inside of the radicand. At the end of our multiplication, we always have to make sure that we simplify, meaning that we look for perfect square numbers that go into the radicand and pull out as many as we can. So let's take a look at a few examples. So question number 1 asks us to multiply 3 root 2 times 2 root 6. So when I multiply my outside numbers together. So 3 times 2 gives me 6 on the outside of the radical. Then I multiply the numbers underneath of the radical. 2 times 6, which is 12. That's the only real new part of today's lesson. But once you multiply, you have to make sure you simplify. So you have to look at the radicand, see if you can split the radicand into a perfect square. So think about your list of perfect square numbers. Perhaps you want to write them up at the top of your paper. This time I'm going to just do the list through 10 squared. So if I'm trying to find a perfect square number that goes into 12, I look at the perfect squares less than 12. So those are 1, 4, and 9. And I find the biggest one that goes into 12. So here, that would be the 4. So the 6 in front of my radical just gets brought down. But I'm going to split the square root of 12 into the square root of 3 times the square root of 4. But the square root of 4 is 2. Remember, when that 2 comes out of the radical, it gets multiplied by the 6. So 2 times 6 gives me 12, radical 3. I know that this is my final answer because there are no other perfect square numbers that go into 3 greater than 1. Let's do the same idea for question number 2. So when I multiply 2 root 6 times 7 root 3, I multiply the outside numbers together. 2 times 7 is 14, and that stays out of the radical. Then I multiply the inside numbers together. 6 times 3 is 18. Now I look for a perfect square number that goes into 18. So if I look at my list of all of the numbers less than 18, 9 goes into 18. So 14 stays on the outside. Square root 18 is broken into square root 9 times square root 2. The square root of 9 is 3. When that 3 comes out, it gets multiplied by the 14. So 14 times 3 is 42, root 2. There are no perfect square numbers that go into 2, so this is my final answer. We're going to be using some of the skills that we learned in the last chapter when we did the distributive property, multiplied monomials, binomials. So those properties are going to come in handy when we start looking at questions like number 3. So in question number 3, in order to multiply a single term by a binomial, we're going to use the distributive property. So take one part at a time. So when I multiply 3 root 2 times 4 root 3, I multiply the outside numbers together. 3 times 4 gives me 12. Multiply the numbers under the radical. So 2 times 3 is 6. when I distribute now to the second term, 3 times 6 on the outside gives me 18. And underneath of the radical, square root 2 times square root 2 is square root 4. Then we look to see if we can simplify any of the radicals. 12 root 6 cannot be simplified anymore. There is no perfect square that goes into 6. But when I look at the second term, 4 is one of our perfect squares. The square root of 4 is 2. So when that plain old 2 comes out, it gets multiplied by the 18 that was already out front. So now I have 12 root 6 plus 18 times 2 is 36. Remember, we can only add radicals that have exactly the same radicand. So 12 root 6's cannot be combined with the plain old number 36. So this is our final answer. In question number 4, again, we're going to use the distributive property to multiply our radicals. So when I multiply the first two terms together, 5 times 3 on the outside makes 15 outside of the radical. Underneath of the radicals, 3 times 2 is 6. Then we have our minus sign. When we distribute to the second term in parentheses, here we don't have a number outside of the radical symbol. It's understood to be a 1. So when we multiply the outside numbers together, 5 times 1 is just 5. Underneath of the square root sign, 3 times 3 makes 9. Now check each term to see if you can simplify the radicals. There is no perfect square that goes into 6, so the first term stays as is. In the second term, 9 is a perfect square number, so the square root of 9 is 3. When the 3 comes out of the radical, it multiplies by the 5. So we end up with 15 root 6 minus 15. Again, these are not like terms. They do not have the same radical. So this is our final answer. Okay, question number 5. Here we are multiplying two binomials together. So to multiply binomials, we have to use the FOIL method. So for question number 5, we're going to begin by foiling this. Be very careful and try to keep each piece separately because you end up with quite a few terms, but we'll see what happens. So when we multiply our first terms together, we multiply the outside numbers. 4 times 5 is 20. And then the numbers under the radical, 6 times 3 makes 18. For our outer terms, so 4 root 6 times 7 root 5, we get 28 times the square root of 30. Our inner terms multiply negative 2 root 10 times 5 root 3. So our answer is going to be negative. On the outside, 2 times 5 is 10. Underneath of the radical, 10 times 3 is 30. And for our last terms, we have negative 2 root 10 times positive 7 root 5. So this is going to be another minus, and this should be 14 root 50. Notice that the middle two terms here combine together, just like they did when we FOILed many of our polynomials. So I would combine those two terms together first. So 28 root 30 minus 10 root 30 makes positive 18 root 30. At the same time, I'm going to look to break down some of my radicals. If I look at the very first term, 20 root 18, I know that the perfect square number 9 goes into 18. So I'm going to break this into 20 times the square root of 9 times the square root of 2. But the square root of 9 is 3. So I have 20 times 3 times square root 2. So the first term becomes 60 square root 2. The middle two terms that I combined together to get 18 root 30, there's actually no perfect square number that goes into 30. So this term is as simplified as it can get. So I'm going to simply bring it down. So plus 18 root 30. And now if I try to simplify my last term, the perfect square that goes into 50 is 25 times 2. So this last term is going to become negative 14 times the square root of 25 times the square root of 2. But the square root of 25 is 5. And negative 14 times 5 makes this negative 70 square root 2. Now that we simplified each of the radicals, notice that we ended up with another set of like terms. I can combine 60 root 2 minus 70 root 2. So 60 minus 70 makes that negative 10 root 2 plus our 18 root 30. This is our final answer. I know that because each of my radicals is as simplified as they can get. There are no more perfect squares that divide into the radicand. And I cannot combine these two terms because they are not like terms. They don't have the same radicand. And finally, for our last example, we're going to look at squaring a binomial with the radicals. Remember that to square something means you multiply it by itself. Don't get fooled by this one and try to just square each of the terms that you see. You have to rewrite this as two separate parentheses. So the square root of 8 minus 3 root 2 times another square root of 8 minus 3 root 2. Squaring means you multiply something by itself. So I multiply this parenthesis by itself. And then again, we're going to use the FOIL method to multiply out these two binomials. When I multiply the first two terms together, the square root of 8 times the square root of 8 makes the square root of 64. For the outer two terms, outside of the radical signs, I have a 1 times a negative 3, so that makes minus 3. Underneath of the radicals, 8 times 2 is 16. For my inner terms, I'm multiplying negative 3 root 2 times the square root of 8. That makes negative 3 times the square root of 16. And for my last terms, negative 3 root 2 times another negative 3 root 2 makes positive 9 root 4. Just like in the last question, my middle two terms do combine together. So negative 3 root 16 minus 3 root 16 makes negative 6 times the square root of 16. Then I'm going to look to simplify each of my radicals. Luckily, we have a lot of perfect squares here. So the square root of 64 is a perfect square number. So the square root of 64 is just an 8. For those middle terms that I combine together, negative 6 square root 16. 16 is also a perfect square. The square root of 16 is 4. So when that 4 comes out of the radical, negative 6 times 4 makes the middle term negative 24. And in my last term, 4 is also a perfect square number. The square root of 4 is 2. So this becomes 9 times 2, or 18. If I put all of these terms back together, and I'm just going to rewrite it so that it looks a little bit neater all together, I end up with 8 minus 24 plus 18, which ends up being just a positive 2. You may have asked yourself why we're bothering to do this. Number 6 is a perfect example. This big mess that we started with at the beginning with all of those radicals is just the number 2 in disguise. And we didn't know that until we simplified, FOILed, multiplied everything out. All of that just gave us the value of 2. Tonight's homework is attached to this note sheet. Please make sure that you show your work for every question. You will not get credit if you don't have the work. You certainly cannot do these in your head, neither can I. And then we will look at moving on tomorrow. I hope you have a great day.